For our new unit, we are finally moving away from triangles, and now we're going to go to four-sided figures, so not a whole lot different, kind of like two triangles put together. After this, we'll go to polygons, so lots of sides, 5, 6, 7, 8, and then after that we will do circles. For parallelograms are going to fit under our quadrilateral or four-sided shapes category. That's the bulk of what this unit is about. Parallelograms will include rectangles, round by squares. That's what we'll do next time. Quadrilaterals will also include kites and trapezoids. That's what we'll do to finish off the unit. So our topic for today is parallelograms. The biggest thing in this unit is going to be memorizing the properties for each of these specific shapes. I think instead of warm-ups each day, we'll make a note card for the shape we learned in the last class. For parallelograms, this is the shape that has the most things to memorize, and then other shapes share a lot of these properties. Parallelogram kind of just looks like a slanted rectangle. When you name any four or more sided figure, you have to go kind of circular when you label it. So if I want to name this ABCD, A, B, C, D. So I kind of had to go in a clockwise rotation for my labels. I can't just put the A, B, C, D wherever I want. So now that we have discussed labeling, let me draw that back up here. A, B, C, D. The easiest way to memorize the properties for the parallelograms are there's two about the sides, two about the angles, and one about the diagonals. So parallelograms are sad. The first property should be the obvious one. In a parallelogram, opposite sides are parallel. Okay, it says that in the name. Parallelogram, opposite sides are parallel. The other side property is that opposite sides are congruent. So if I look at my little sketch over here, opposite sides are parallel, so that would imply that AB is parallel to DC, which we can mark with the arrows. But it also says opposite sides are congruent, so those can also get a tick mark. Likewise, AD is parallel to BC. Those can have double arrows. They're also congruent, so double ticks. Our third property, and our first of our angle properties, is that opposite angles are going to be congruent. Meaning, if angle A is 100, angle C is also 100. Consecutive angles, meaning angles in a row. So, consecutive angles, I'm going to put are equal to 180. Really, they're supplementary, I just can't fit that word. So what that means, angle A is consecutive with angle D. So those should add to 180. So D is an 80-degree angle. I also could have said angle A is consecutive with angle B. Okay, so really next to, that could be up and down or left and right. So angle B is also 80 degrees, which should make sense because we said opposite angles are congruent. B and D are both equal. For our last property, I'm going to draw another little sketch because that one got kind of messy. Every shape is going to have special diagonal properties. For parallelograms, the property is that diagonals bisect each other. It doesn't mean they're equal to each other. It means they cut each other in half. So if I connect DB and AC, that's telling me that DB is cut into two equal parts and AC is cut into two most likely different equal parts. Okay, so we have two pairs of matching pieces. We're going to look at some of these examples. I may draw some of these pictures a little bit bigger because they are a little bit hard to work with. The first four should be okay though. Before I even look at what it is I want to solve, I actually just go through and mark everything possible in my picture. I know this is a parallelogram, so I know my opposite sides are going to match, so this will be 15. This side AD will be 8. That's everything I can do with my sides. I know my opposite angles are congruent, so 68, 68. And then to get angle A and angle C, I'm going to do 180 minus 68 because, again, those consecutive angles, so angles next to each other, should add to 180. And that's going to give me 112 degrees for those angles. So now I really have everything that's drawn in my picture labeled. I just need to fill in my answers. So the first one I asked about is AD. AD is right here. We said it was 8. DC is down at the bottom here. We said that was 15. Then angles, so we go inside. Angle A is going to be that 112 that we found. Angle B is going to be 68. And angle C was also 112. So again, the easiest thing to do is kind of mark your diagram up as much as possible and then just fill in your answers. So on number 2, again, you could go through, this is 21, 21, JM's 29, KL is 29, L is 127, J is 127. I do 180 minus 127, I get 53. So M is 53, K is 53. And then again, you're just filling in. So JK was 21, KL 29, angle J 127, angle K 53, and angle M was also 53. What makes it a little bit trickier is when we start having the diagonals drawn and we have to label a lot more in our picture. I do see that for number 3, there's no angle question, so this picture I should be able to work with. Again, I know that these two opposite sides have to be congruent, so ST is 18. If RS is 27, UT is 27. Then if I go inside and I'm looking at my diagonals, UV is 7, meaning VS is also 7 because diagonals bisect each other. To get VT, I need to look at a statement given below. They tell me that RT is 30. RT is this whole thing. So if I cut that in half, each part is 15. So VT is 15. This next one is where I'm going to start drawing these pictures separately because it does get a little bit kind of ugly. So if I look at number 4, they gave me parallelogram C, D, E, F, and they do have the diagonals drawn in there. You can always draw the picture bigger if you need to. They told me this is 21 degrees. They also told me that this angle here is 71. And they told me that FED is 134 degrees. FED is this whole angle. that's really hard to actually label in my picture. So I'm going to go ahead and do 134 minus 71, since I already have the 71 portion of the angle. So when I subtract the 71 out, I get 63, meaning the rest of this angle here is 63. So right now, that's kind of everything they've given me to work with. At this point, I can start looking for parallel lines, and I can start looking for parallel lines, and I can, I don't know what that is. I can start looking for parallel lines, and I can start looking at triangles and all that kind of stuff. If I look for parallel lines, remember the easiest thing to do, take a highlighter. I see CF and DE. If I want to connect those with a parallel or a diagonal line, that's where I would connect them. And remember that the angle is where we bend, so 21 is going to match my angle where I bend again. So 21 is over here. I can also do that with my other angles. So I can take CD and FE and connect them. So in this case, 71 is in this bend, so 71 is up here in the top bend. We know 63 is next to 71. Sorry, 63. So now, if I look at this, I could go ahead and say, okay, well, if I want to find this angle here, I have a triangle. I don't know if I need that angle, but I have a triangle, so I can go ahead and do 180 minus 21 minus 63. When I do that, I get 96. This is 96. It's vertical to this, so this is 96. Okay, but angles that make a straight line add to 180. So 180 minus 96 is 84. This is 84 and this is 84. And finally, I can find this angle here because I know that these should add to 180. So 180 minus 84 minus 71 gives me 25, which has to go next to this other. So at this point, I have found every possible angle they could ask me about. They asked me about the measure of angle DEC, the measure of angle CDE, and the measure of angle ECD. And lastly, DFE. Because they're all angles, I know whatever angle they want is up their side. So now I just have to go through and let's say DEC. So DEC is that 63-degree angle that I had here. 63 degrees. CDE. CDE is that whole angle up there. So if I put those together, I have 46 degrees. ECD, if I follow that, ECD is that 71-degree angle I have. And last but not least, DFE is going to be that 25-degree angle right there. So it is a little messy. That's why I said I would draw the picture bigger. But because I did all my angles ahead of time, I just had to find them when I went to fill in my answers. So go back. At this point, your notes should be filled out. This was 63, 46, 71, and 25. Let's go ahead and look at 5. I'm going to skip 6 because it's going to work the same way as 4 did, where you need to find all your angles and then just fill in all your answers. If you want to try it on your own, I do have the answers, so I can post those as a PDF so you can check them. For 5, again, I'm going to go ahead and draw 5 out as well. So on 5, we again have a whole lot going on. We have W, X, Y, Z. We have our diagonals drawn with T in the middle. Then we have a lot of information. They tell us X, Y is 15. Okay, but remember, if that's 15, so is WZ. They tell us WX is 22. Well, if that's 22, so is ZY. ZX is 52. ZX is this whole thing. It's too hard to label the whole thing as 52. Luckily, they bisect each other, so we can just say 26. 26. WT is 23. Notice this time that WT is just that half portion. So I don't need to cut it. That is 23. This side will match and be 23. Then they go ahead on to angles. They tell us that angle WZY, so that whole entire angle, WZY, that whole angle is 72. Okay, that's not really helpful to us, so I'm going to kind of just make a note here that the measure of angle WZY is 72, because I'll probably need that later. WXT, if I go and look at WXT, that I actually can label. WXT is there, so we can say that's 35. Okay, but remember, if that's 35, finish your Z, that means this angle down here is also 35. Okay, opposite corners. This is where I can use that 72. If I do 72 minus 35, that leaves me the, let's see, 37 degrees for here, and finally they tell us ZWT is 59. ZWT is 59. If I continue my Z, this is also 59. Lastly, if I want to know those kind of middle angles, I can figure that out too. 180 minus 37 minus 59 can help get me kind of that one angle that I need. If I subtract those, I have 180 minus 37 minus 59. I have 84. Okay, well, here's my 37, 59. This has to be 84. Because that's 30 or 84, so does this. But if I subtract that from 180 because of straight lines, then these are 96, 96. Well, then I can do 180 minus 35 minus 96. Get the 49 that's left for this angle and this angle. So this picture is very ugly. You don't really need all this work outside anymore, but I do need to go answer all of those questions. So when I do that, it has ZW, ZY, TX, WY, measure of angle TZY, measure of angle XYZ, measure of angle XWT, and finally measure of angle XYT. Okay, so now, again, everything's labeled. I just have to find it all. So if I go to ZW, okay, here's ZW, it's 15. I go to ZY, here's ZY, it's 22. Okay, I go to TX, that was 26. And WY. WY was 46 because we had the 23 and 23. Okay, so there's all those sides they asked me for. Lastly, we need to look at angles. Angle TZY. TZY. 35. XYZ. XYZ. I have to put those two together and get 108. XWT. 49. One thing that might be helpful is labeling your sides in one color and your angles in the other, because there is a lot going on. And finally, XYT is this 59-degree here. It's ugly, it's annoying, but it ultimately comes down to how do lines work, how do triangles work. So again, in your notes, you should have 15, 22, 26, 46, 35, 108, 49, and 50. Again, I feel like you will be very mad if I do 6, so we're not going to do 6. Going on to the next page. This page is going to be a little more straightforward. Really, you just have to think, are they equal or do they add to something? For number 7, okay, well, they're opposite sides. Sides never add to anything at all, so all I can do is set them equal. Okay, well, if I solve that, if I subtract 5x, I'll have 4x minus 25 equals 7. Add 25, I have 4x equals 32. Divide, and you have 8. So that's for x. X is 8. We're good. Number 8, same thing. Sides can't add to anything, so all I can do is 11x plus 1 equals 19x minus 2. Subtract 11x, and you have 8x minus 31. Add 31, and you have 32 equals 8x. X is 4. However, they wanted yz. So I need to find yz, so I need to do 19 times 4 minus 31. When I do that, not degrees, it's outside, so just 45. So really, that's the main thing. Make sure you know what you're solving. On 9, they give me TV, which is the whole thing, but we said that's too hard to label. So we said that we would prefer to label that as 37 and 37. Okay, so TV is 74. That meant TW was equal to WV was equal to 37. Okay, but now it tells me WV is 4x plus 1. If WV is 37 and WV is 4x plus 1, okay, well, I can just set those equal. Subtract 1, and I have 36. So x is 9. Use your pictures to help you. You could have doubled the WV to equal 74, but if you're cutting in half on your picture, you might as well keep it that way. On the next one, it tells me that NS is 2x plus 7. It tells me that SQ is 5x minus 23. Okay, well, those are two parts of the same line. So 2x plus 7 has to equal 5x minus 23. Subtract 2x, and you'll have 3x minus 23. Add 23 to get 30. Divide, and you will get 10. It asks me for NQ. NQ is the whole thing, but I can just plug into both parts and figure out what's going on. So 2 times 10 plus 7 is 27. And then 5 times 10 minus 23 is 27, which is what we hope for. When I put those together, I get 50. Couple more here. 411, they want angle B, so I'm going to go ahead and write that over here because I will probably forget. They gave me A and C, so I know opposite angles are congruent, so I can solve that. Subtract 4x, you'll have 2x minus 15 equals 11. Add 15, you'll have 2x equals 26, so x is 13. Okay, but remember, our goal is angle B. Well, if x is 13, then the measure of angle A is 6 times 13 minus 15. When I do that in the calculator, I get 63. Angle B and angle A are supplementary, so if I do 180 minus 63, I will get angle B, 117 degrees. So it's really important you understand how all these things relate, because it is going to be a longer process. If you look at 12, 12 is a little bit different. On 12, these two angles are next to each other, not opposite. If they're next to each other, I have to add them to equal 180. Okay? We set them equal if they're opposite each other, so diagonal. If they're up and down or left and right, we add 180. So 8x and 3x is 11x. Negative 12 plus 5 is negative 7. Add 7, we have 11x equals 187. If you do that divided by 11, you will get 17. It asks for angle R. So again, we have to look, x is 17. Angle R is going to be the same as angle P. So I just need to do 3 times 17 plus 5. When I do that, I get 56. Okay, we've made it down to the bottom. Let's do these two. Angle KLH, so KLH is 134. I'm going to need to use that sometime. Okay, so this is 134. I know that that angle and this angle should add to 180. So I do 180 minus 134. I will get 46. Minus the 25 that's already there, and I get 21. So this here is 21. But if I remember what I learned with parallel lines, always look for that Z. this is 21 here, then this up here is 21. So 4x plus 9 equals 21. There's a ton of different thought processes to get there. If you're looking at this totally differently, that's fine. You just need to try and connect parallelograms to parallel lines, triangles, alternate interior angles, all of that stuff. I have 4x equals 12. X is 3. It said solve for x, so we're good. Last but not least, angle ABC is 115, so that whole thing's 115. However, if I think about my, Z, if I connect this angle to the other line, that means this angle here matches this one here. But we just said that this entire angle here is 115. So I can say 4x plus 6 plus 6x minus 11 equals 115. 4 and 6 is 10x minus 5. Add 5, I have 10x equals 110. X is 11. They want an angle ADB. Okay, well, here's ADB. So 6 times 11 minus 11, 55. Okay, let's see how we're going here. I know this video is getting long. Okay, we need to do a couple more things. You can prove parallelograms in a coordinate plane. I'm going to tell you all three options. I'll do one of each and then kind of call it a day. Option 1 for proving they're parallel is that you show both pairs of opposite sides are congruent. So if AD is congruent to BC, these two, and AB is congruent to DC, so the top and bottom, then we would have a parallelogram. That would really just mean we have to use 4 distance formulas. To show that opposites match. Better than the 6 we were doing in triangles. Method 2 would be to show that both pairs of opposite sides are parallel. So we could show that AB is parallel to DC. We could show that AD is parallel to BC. Then we would have a parallelogram. Parallel has to do with slopes, so you would be doing 4 slopes. The opposites would both have to match. That is what I would recommend. That's my preferred method because slopes are easy. Your third option is to prove just one pair is both congruent and parallel. So maybe I do AB is congruent to DC. If I show those are congruent and that same pairing is parallel, that would also be enough to say it's a parallelogram. And by default, the other sides work. So that would be 2 distances and 2 slopes, showing that both match. So then you'd have to make sure you pick the ones across from each other. So if I look at number 1 here, I kind of sketch this out, really rough sketch. A is -7.4, so up here somewhere. B is at 1, 2. C is at 9, -8. And D is at 1, -6. So let's say here somewhere. So we have something that looks like this. This at least gives me an idea of what to compare. For method 1, again, I'm doing distance formula. Because I want to do opposites, I need to compare AB and DC. I'm going to start with those, then see if I have to keep going. So if I'm doing AB, I would have square root of -7 minus 1 squared and 4 minus 2 squared. That's going to give me square root of, let me see, square root of 16. I'm not going to simplify because I really just need to see if I have a match. Okay, for DC, I'm hoping to get the same thing. We have 9 minus 1 squared and -8 minus -6 squared. I go type that in. I get 68 again. So those two are a match. So as of right now, I know AB is congruent to DC. If they didn't match, I would be done with the problem. They do match, so now I need to check AD and BC. Okay, so AD is going to be -7 minus 1 squared and 4 minus -6. 7 minus 1. I get square root of 164. Again, I don't actually care what the length is, I just want to match. For BC, I'm going to have 1 minus 9 squared and 2 minus -8 squared. Is 164. They match, so AD is congruent to BC. Therefore, A, B, C, D is parallel. Again, it's only 4 distances in step 6. Could have been worse. I'm going to leave number 2. If you want to do it, great. I can check you, but I'm not going to do it. For number 3, we're doing slope formula to check. So again, I'm going to kind of sketch this out. W is at -7, -4, so I don't know, there-ish. 1, -6 for X. 5, -13 for Y, and 1, -12 for Z. Okay, I'm going to move Y down because it should be further from here. Okay, so we have something like this going on. It's not my prettiest drawing, but it's the point across. First, I'm going to check if WX is parallel to ZY, because based on my picture, it sure doesn't look like it, but my picture's off. So, WX, if I want to do slope, -4 minus -6 over -7 minus 1 would give me 2 over -8 to -1. That is for WX. For the slope of ZY, I would have -13 minus -12 over 5 minus 1, which is -1 over 4. These are parallel, so I know WX parallel to ZY because they match. So I do have to check the other two. Okay, for the slope of WZ, I would have -4 minus -12 over -7 minus 1, which is 8 over -8, which is -1. The slope of xy would be negative 6 minus negative 13 over 1 minus 5. Which is 7 over negative 4. These two do not match, meaning WXYZ is not a parallelogram. So we didn't have two matches for our slopes, so I know it's not a parallelogram. Last, for real last this time. If you don't want to do the whole sketch, remember J, K, L, M. We go clockwise, so J and L are always going to be across from each other. So if you can do this sketch, you can decide, okay, I'm going to do J, K, I'm going to do L, because they're opposite each other. So as long as you can kind of label it, you're good. If you want graph paper, take graph paper. I want to use distance and slope just for J, K, and L. So for J, K, my distance is going to be negative 9 minus negative 5 squared and negative 2 minus 1 squared. That's going to give me square root of 25, which we don't know is just 5. For my slope of JK, I have negative 2 minus 1, or negative 9 minus negative 5. It's negative 3 over 4 over negative 4, which is 3/4. I need to check LM. Length of LM is 1 minus negative 3 squared, negative 4 minus negative 7. That will give me, let's see, hopefully I'm not taking things wrong. Sorry. 25, no, that's 5. So far, we have our distance matching. We need to check our slopes. We have negative 4 minus negative 7, 1 minus negative 3. On top, that gives us 3. Bottom is 4. They match. Therefore, JKLM is parallel. Okay. Any problems I didn't do, you're welcome to do on your own. Otherwise, your homework in the homework packet is pages 1 and 2. So just that first page, front and back.